the cloud. Okay, thank you, TJ. Can you start from the first slide? Yeah, because the class is nice.
Sorry about that. All right, everyone, thank you all for listening in on this. I was very interested about this paper because back in May of this year, DeepMind came out with what is the basically white paper on arXiv about this and sort of a splash post on their website about what this general agent tokenization optimization, or GATO, is. Currently, it is a step towards AGI, and it's very controversial in the field right now, especially it blew up Twitter because there are both claims that it is an advancement towards artificial generative intelligence, where a lot of people are saying this is just more specified, narrow AI and is very task dependent. I'm going to go through this paper and try to make arguments for or against, but the main takeaway that I want you all to sort of think about during this is whether or not this is actually helping the argument on whether or not we're actually generalizing our agents, or we're still in the realm of narrow AI. And for those who don't know, narrow AI is very much just trained on very specific tasks, like AlphaGo is considered narrow AI due to the fact that it's training only on Atari games, where you can't necessarily just take that out and use robotics. So to give you a little context on this year, we'll come back to this later. Language models are a big thing with DeepMind. And so I wanted to post this here in terms of the parameter size and the model size of a lot of these. And so Gopher came out end of last year, Chinchilla came out, same with Flamingo. Each of these are what Google is now using in their chatbots, in a lot of comparisons to GPT-3 in that area. GATO is relatively small. It's at 1.2 billion parameters, and specifically they comparatively in terms of orders of magnitude compared to the language models.
No, I'm looking at the others. Look,
Yeah.
280 billion.
It's funny to know, I have to say it's small.
Yes, but they chose it specifically because they wanted to make sure that their models could fit on an RTX 3090, which is the state-of-the-art NVIDIA processor that they use for all the robotics tasks. So with that in mind, in going through this, what I want to cover today is to go over the general concept of model architecture, performance in terms of positive, negative transfer, some scale considerations, the ablation study, and the steps forward. And just like I said, I'm very curious what you all think about this AI discussion, AGI discussion. So GATO, what is it? It is specifically trying to generalize tasks and tokenize different domains. So specifically, they were looking at vision tasks, they were looking at language tasks, and they were looking at motion tasks. And so they tried to get three of the major senses to sort of like think about what a general robot might do, and whether vision tasks could help with language tasks could help with motion tasks. And so they trained on 604 tasks. And so we'll get into more details, but just for example, and I don't know if the resolution is great on this screen for everybody in the room, but they have things like MojoCo where they're doing sort of walking simulations, or like the spider simulations. They're doing Atari, where it's taking in the screen and reward functions for that. They're doing language models in terms of labeling pictures. They're doing chatbots. They're doing labeling of images and not just captions. But with all of those, they are essentially the top left sort of block of this is how they tokenize. And this is the cartoon they have in the picture and on their website as well. But specifically, they take each of the different modalities and they end up tokenizing it in a very regimented way for each of the three, either language, physical tasks, or visualization tasks.
Do you understand like the details of that part?
Yes, and I do have. Can I actually look at my slides? No. Okay. Sorry for the whiplash. So a lot of this is transformer based. because they're looking at concatenating on all of the tasks at once to add into the transformer as the agents learn. And so there are images and sort of the different tasks that it can represent as well. And they're each stored as a representational vector. So the same way a language model might do that, where they take cat or dog, instead of like an alphabet, instead of just a numeric index of where it might be in the dictionary, it's going to be encoded as like a 5-shot vector, or it's going to be encoded as an n-shot encoder.
So you take an image,
Mhm.
cut it into smaller images, make vectors of them, assume it's a sequence, and then run it through transformer to create the same length sequence of vectors, concatenate them, tada, you got the vector.
Bingo. And so they also have a ResNet block to tokenize some of the image patches, just like you said. And so that's running in terms of the image tokenization part. I'm going to whiplash everybody again. I apologize. But I wanted to stop here. So in terms of the tokenization, we're jumping, and I apologize for the text. This is extracted directly from the paper itself. But they try to tokenize both the subwords. Each of the images are transformed into different patches, and they're not overlapping. They try to keep mutual information, but structured information together. They have discrete values in terms of the time course sequence for the actions of the Atari games. So if we like go left or right in Space Commander, that would be deemed an action within that sequence. And then sort of continuous values are going to be in terms of like joint torque, or a lot of the things you can get in robotics is also going to be tokenized as well. In terms of specific domains, I don't have a lot of robotics experience, so I can't get into those nitty-gritty details, but some of the vision stuff I can. But they try to aggregate them all into batched inputs that they are going to train on GATO. This one thing I need to make sure that I note here is that they are doing fully supervised learning. This is not reinforcement learning. So all the tasks are already done that they're trying to learn from. And this is not feasible yet in terms of online update. And so with that, they took 16 days on like massive TPUs to train this whole model. And I'm pretty sure they were using, I want to say 32 of the Titans or something, but it's nothing to slouch at.
But all these tasks are also like they're disparate, right? You don't have like tasks that have similar context, or like the movement tasks are not from the same robot, or
Bingo. Yes,
Yeah.
Great question. So these are all the tasks. And what I don't have ready, and I apologize, I don't know if you can see, if I can annotate a little bit, but in terms of what they sort of are, the left is going to be more robotics tasks. These are going to be physical tasks that are already laid out, whereas the right are the vision and language tasks. And so what I want you to notice is that 85% of the training data is on the physical task itself. And so they're only doing 14% or 15% adding in sort of vision and language. So it's actually not a great split in my opinion, but they just wanted to throw the kitchen sink
I mean, it's
at this problem.
interesting. I'm trying to. This is getting into like actually how organisms learn, right? Which is like
Sort of.
you know, but it's like so different how any organism actually learns, because like you know, if I'm looking at a bunch of images, I'm in a room and using motion to pick up a card and look at an image and associate a label with it, and that it's like all these interrelated processes, right? These are very disparate.
Yes, and that is actually one of the motivations of this paper too, is the
Right.
fact that they're trying to take a single policy, a shared policy of this tokenization, and learn across all of the different types of learning that they
Yeah.
can find. And so they're saying that this is diverse enough to add additional information to mitigate some of this outer distribution learning that happens. And we'll see if that's actually true or not. One thing, did I skip a slide? I did. One thing I just wanted to show, I want to stop annotating. One thing I did want to, my slides. There we go. This is just a nice little visualization. I don't know how to get rid of my annotations, I'm sorry. Clear, thank you. Clear all my drawings. Thank you. Okay, so just as a fun visualization, these are some of the biggest models to date. I pulled this. This is April 2022. GPT-1 and GPT-2 are those little dots to the left. In terms of how the model parameter size of GATO is, it's between those two dots in terms of size. So things like Gopher that came out earlier or December 2021. That's massive, or Palm is massive, and these are all language models. And so their idea, DeepMind, is to throw the kitchen sink at it and show initial proof of concept before they start scaling. So the goal is to not perform the best at all of these tasks, is to perform moderately well at a lot of tasks, if that makes sense. So instead of fine tuning it, but Google has also stated that they're gonna just scale this up. But I just wanted to give context of where this stands in terms of other models out there. Cool. This is an example of one of the tasks they have. Reason why they give different triplets in terms of the tokenization on this specific task is the difference between placing a red cube on top of a yellow, or on top of a green cube, is going to be very similar in coding to a green cube being put on top of a red cube, or vice versa. And so they sort of have a soft start. I'm going to give you whiplash here, and I apologize, but I wanted to explain sort of what this is doing down here. They end up giving an initial, like, almost like a soft start of what the model should be performing. So to give that context of whether it should be red over blue or blue over red, in terms of like what a robot, or like a robot should stack. So it does give a little jump start to what the model should be predicting. Great. Clear all drawing.
That's interesting. That's what I was kind of wondering if they did, right?
Yeah.
So they give it like some kind of
Initial,
initial input, they tell it how to do something, that lines up with.
So it's
But then these other
not
tasks are
just-
totally different, right? Like the Coco image captioning and stuff.
Yep,
Yeah.
exactly. So it's not just even an initial condition, it is a fixed prompt, right, too. So it's either an encoding of an image, it's like what do you want, sort of the initial steps of like moving to red, or the actions of torque or something. I'm not quite sure in terms of robotics, but I do know that they give a sequence of initial starting values.
Interesting.
Can they use that? So do they use that to create the initial embeddings?
Yes, it essentially would be they give the initial embeddings. Okay. Yeah. Great. We got through that. This is the interesting and kind of the bigger results. And I'm going to actually come up to the board because I think it's kind of interesting. One thing that this is showing is this is the expert score from all the tasks. And so here they're trying to show the different types of tasks. So this is going to be more motion based down here in terms of the physical world at 50%. So it's trying to get as good as an expert might be able to play these games. So if like I'm the world champion at Go, I should be able to win Go.
That's also what it's training on, right?
Yes, and so these are hand-tuned sort of quantifiers for all of this, but what they're saying at 50% of GATO performing as well as the expert, you're still only getting not all of the number of tasks that could be trained on. So a lot of these upper tasks here are going to be a lot more complex. Like I believe these are going to be more visual tasks and more language tasks than actual physical tasks. And so even at 100% accuracy, so if the model is perfect at achieving expert level accuracy, it's still only getting physical world models. So it's still only performing about 200 of the 604 tasks at perfect expert level. So what this is really showing is that it's okay at a lot of things, but not great at a lot of things either. So it's generalizing, but not doing anything well, if that makes sense. So that is one of the counterpoints to this whole thing. This is the most egregious thing of the whole paper, in my opinion. There is no error bars. They have no variance, period. What they're using VC-imp as its baseline, and this is behavioral control of robotics. So it's essentially doing this whole thing, without language and without any kind of vision. And so they train robotics agents with a lot of different tasks, and BCM already does this, and they're training just on robotics tasks. And so the improvement is 50.2 for GATO and then 49.
It's really small.
Where did this
It's
get
such
published?
what is what?
Where did this get published?
It
Just their
did
white
it.
paper?
I mean,
Okay.
this is archive preprint,
Right.
and then they have a very nice website.
No, I was just gonna say, if they got accepted to a conference, that would be like, there's no way that they didn't know that this was the same group who had all these other models. That's the reason they got accepted.
No, and my thinking with this too is that they were coming out with these large language models, and they're like showing. I'm pretty sure they're still going off the fact that what the David Silver paper, reward is enough,
Right.
came out, and then Sutton had the 2019 paper that they were talking about how scale is the only way up.
Right.
The models aren't wrong, our compute's wrong. And so that's what they keep saying, but it's still like they're not telling the whole story.
Yeah. It's just.
Also, really quick, because I think it's generally funny because it's double blind, but then if you get a paper that says I had 1,000 TPUs training for 10 days, it's definitely not some sort of random academic lab. It's like, who could that be?
Yeah.
It's
Exactly. Right.
yeah, no kidding.
No, you still don't know if it's which of the three it is.
So the big thing that they say and they make a claim about in this paper is that there is more information gained by using out of distribution training in the for like different modalities. So does vision and language actually improve motor tasks? And right now, I'm not convinced. They don't put their error bars there. This is more examples. I don't know if this is gonna be great in terms of resolution for this room, but what I want to point out is sort of like, this is the image was this man, and all it says is a bearded man holding a plate of food. Specificity, not great. In terms of like what it says, like a man smiling while holding a slice of cake. This is not quite cake, but it's still recognizing that there's a person, there's multiple objects within the image.
This is what 50% of the expert score looks like.
But that's what I'm saying. So it's still captioning, but it's a generalized caption. It's not saying like it's at a baseball game, there's wooden counters or anything, like the image length or the caption length isn't great. Oop, I don't want to save those.
But people, that's how people caption those things, right? So that's what it's trained from.
Yeah.
Like people wouldn't describe this whole setting and etc. People would
I
just.
think they're pretty detailed, I think, in like these data sets.
Yeah, this was just one of the examples that they had said, but
I mean, I agree there's like a limit to how detailed it is, but I think they try to make it pretty detailed so that, you know, you can get a really good model.
yeah, I guess even in this one, like a baseball player pitching a ball on top of a baseball field, like other than like saying a pitcher's mound, I think you're probably good with a picture like this. But things that even like Clip and Dolly 2 had issues with was both text generation within an image. So like if you sort of had any kind of text within the image, it started to classify wrong and then label wrong. And then also if you had like a blue object over a green object or some kind of positioning of characteristics you need to give to objects within an image, there are issues with decoding and sort of understanding the relationship between the discriminators of the different objects within the image.
So I want to agree that I'm not entirely convinced by these results either, but for kind of a methodological reason, right? So when humans or even other animals learn, let's just talk about humans, right? Learn to talk about images or learn to, do manipulation that is associated with vision, right? They're not these like very disparate tasks where you're like moving, stacking something on top of each other and then captioning a guy in a bar, right? You are, you pick up an object, you move it around, and this is all this motor activity that you're doing that is then associated with your description of the object and associated with response to the visual cortex and stuff like that. It's very, these tasks are very closely coupled, right? Most of the time, not always. You have teaching and, learning online and stuff, but those are,
But does understanding, so we'll have an ablation study here in a second, but would understanding how to do Atari kickboxing like just the visual of like the very much like two sprites kind of interacting with each other, how does that help you with moving an object around?
Exactly, yeah, I think, well, wait, so what is, I think that's an example of what I'm saying is spurious about this versus what,
Yes and no, and so I actually get to some of those things, but I actually think they hurt the model if you add that extra information in there, especially because they just, their argument, it's not, the model's not big enough.
Well, I was actually gonna say that I think part of why I think it should be smaller in a way, like you, maybe less tasks, but I think one thing that is so nice about the human brain at least is that it has a very kind of like limited, like a lot of neurons are heavily shared.
Yes,
You know what I mean? Like it's not like they're like really shared.
yeah, so they actually do that as well, in terms of trying to look at the scale of their model. They show that their score only gets better by the size of the model. They only do half and 2/3 the size of their previous model. But I don't know, I still think that, I mean, we know that it's,
Yeah, but this to me makes it sound more like narrow AI, right? The fact that, you know,
Absolutely.
it cannot share these things very well and it just needs more parameters, because if you go to the limit of having a lot of parameters, it can just learn to do them all completely separate, because your space is so highly dimensional that you can just separate all the tasks in your embedding space completely from each other. And then it's almost as if you're just training them separately.
no, absolutely. And the head of DeepMind's research right now, the Nando Day critique or Freitas, yeah. These are two of his tweets that he came out with in May. And it's basically saying that it's scale. They have enough scale and they're about to tokenize everything and learn language models of the world. And so these are
like
just,
those tweets, like some of these AI people that have become famous, they're now just like, dude, we solved it.
it's marketing.
I know.
They just want views on the number. They spend millions and millions and millions of dollars. I'm
Yeah,
gonna go
but not
through.
them specifically though, that's why.
Yeah, just a really quick one. This is their text bot conversation. I doubt you can read that, so I apologize. But the middle example again, it says explain the basics of black holes. So I guess I'm trying to answer the simple question, what's a black hole? Indeed, please go on. Black holes usually occur within a star, when a star dies and flows in a runway reactions, typically caused by an expression of the core helium of a star and the fastest when it comes into contact with a very large mass of black hole.
I like that it's gaslighting.
Yeah.
Simple question.
But this is still GATO.
This is still GATO. This isn't Flamingo. This isn't any of the like Como or Coco. Sorry, Gopher. Gopher. It's not Gopher as well. But yeah. So it's giving moderate stuff. I don't know the scoring because it changes every 3 to 6 months on what the standard is to how to score some of these language models. But from my understanding is there's a couple data sets that it could test against, but it definitely didn't, since it's just an archive paper. I just wanted to show off a little bit. Okay.
if you show this to anyone that has built like a database-based chatbot before, they'd be so angry because all these questions are just like things that you can pull from a database directly, right? Right.
All right. So this is the crux that I think
They are. It's just like, what does this
Well, but I
mean?
can
What is this?
disagree. Yeah, but I can disagree with you in terms of GATO. Like, it doesn't have enough parameters to remember that stuff. That's the demonstration, and it still kind of remembers those pieces as a knowledge base. It stores them somewhere.
I agree with that, but at the same time, they kind of say that they want to go bigger, so they essentially, they're, so that's why their conclusion is also like a little bit backwards. So they're like, we should go bigger, but then you get what Brad is saying, even more.
Yeah, well, but
So-
in the limit you get GPT-3,
Right,
right?
that's what I'm saying, and then you just
Chinese
pull
roll.
whatever, yeah,
Yeah.
it just becomes a huge database. That's why I'm like, why is the conclusion we should go bigger?
Because they also make the claim that in the next 5 years, there's going to be more data generated than what we have currently
Right.
in all of digital media.
I have multiple answers. One is moats. The companies needs the moats around them, and like, okay, if we go bigger, no one else can do it, and then we.
Oh, that's
yeah.
fair.
Yeah, oh yeah.
Another one is, well, maybe it's good for economy if we pour a lot of money in creating more hardware, larger scale. Well, anyways, It's like,
Well, I think, so I think the model will get better, right, with more data, more compute, but then I think the conclusion should not be, we're making AGI happen. The conclusion should just be, look, we have enough data and you guys don't, and we have training and you guys don't, which is fine. I mean, literally, that's what it is, right? And that's also what they're doing, OpenAI is doing, like, they're just kind of like gatekeeping compute and stuff, but that's fine, but then don't claim that it's AGI, you know what I mean? Like, it's like,
But that's
Oh.
how they're getting funding.
no, I know, but it's crazy though. Like, the conclusion is just like completely the wrong way. It's just-
just to be devil's advocate, and just because I like arguing, but why wouldn't it be AGI if one single company that has all hardware in the world creates it, and it is actually, yeah, like no one
One
can
single
use it.
company who's a massive media sort of powerhouse, right?
No,
This
no,
is
but I
not like-
think I mean, even then, but my point is more the fact that, like, if you go bigger, you get less share, like, things, right? And I
Yeah,
think
yeah.
you get more narrow AI. That's, I think, what is like happening. If you increase the parameters and you get better scores, I think that's just because you can separate the embeddings of your tasks that are in the space, right?
But I think it also has to do with being first in the market.
No, right.
If they're using Gulp, they're using Flamingo within their own system to do the recommendation of the chatbots.
Mhm.
Even think about like the iPhone. People weren't putting music players and the internet on phones. Really, BlackBerry was kind of doing it, but it was the marketing of Steve Jobs that was able to amass that. So I think what Google is trying to do as well is to coin the AGI thing. But my issue with that as well, and sort of a grander argument, is that the first two winters that happened with machine learning happened because they started making claims about general agents or
Exactly.
general learning.
Right. It's just a little bit of a grip in my opinion. Like, it's just like, it's very impressive, but you don't have to you know what I mean? Like, the thing to me is, like, there's a lot of these papers, like articles coming out too, like, they won over the critics last time, and this time is no different. And it's like, you can claim these things without over claiming them, you know what I mean? This is an impressive model by itself.
Yeah.
You don't have to say it's AGI, like, it's already cool.
Yeah.
Like, I don't know why it has to be then all of a sudden the epitome of everything.
I think there is a difference between sort of clever Steve Jobs style marketing, where you're taking a product that has real value and you're really pinpointing the things that people want from it and being able to sell it well, versus overselling something that.
Right, just we also have heard about GATO, but we haven't heard about VCM. Like, I could explain that, but that's also a very well-known group that are doing that out of Stanford.
No, sure, I agree with that, but I don't think that
that's
person.
really marketing.
Yeah,
Yeah, but I don't think they have to do AGI marketing to get it out there, though.
Yeah.
I think that's just what.
but
they
that's
choose
the
to do.
easiest way to explain to people who don't know that.
I mean, that's the reason it was so famous, because I don't think everyone read this paper. It's just like when they heard the AGI, they're like, okay, yeah.
I actually didn't know, but I did know the paper. I didn't know they said AGI about this. I just think that's not true, because Google has so much money. Like, they can also sell their Google Home. They don't sell it, say that's AGI. You know what I mean? You can sell things without saying they're AGI. That's my opinion. Like, I don't know why they have to do. It's the easiest way.
Same thing.
It's the easiest way for sure, but it's not.
things a cloud. It's servers.
Yeah, but sure. But that's just.
But that's how the general public knows that it's just in the air. We can just make computers think now.
You can call it AI too, you don't call it AGI.
I think it's like, that was a good point, TJ. It's a sociological thing. We keep renaming things in every generation.
Yeah, but that doesn't
Because-
mean it's right.
Oh, but I mean, it's been continuing for 1,000 years.
I mean, like Transformers.
This is a terrible name.
Yeah, it really is.
You mean they're not robots in disguise? Wait.
Yeah.
There's a difference between misnomers and literally saying that this can do what humans can do, because that's what they were tweeting. I also saw those tweets. That's
yes.
my point.
No.
I'm not saying that the name, sure, we can call like, oh, the names are different and they change every year, sure, but I mean, they were literally saying that this is like now as smart as.
Yeah, no, that's not the case. I mean, even for that, especially for the NLP part, if you see like most of the examples that you showed,
Right.
it's like very specific to what they're asking. It's not a very vague.
No, exactly.
So they're not even asking any questions which might not have any answers.
Yeah, can I
So
throw
that's-
another wrench in this whole discussion? So this specific plots, I really like this. This is where I think their argument starts to fall apart. They tried to do an ablation study, sort of what we were talking about in terms of adding in same domains data or specifically out of domain data. And they were looking at whether or not to use all of the language, physical and vision tasks, or just some kind of ablation of it. So with Cartpool, they're still doing action-based training on some of the other tasks, but they aren't training on Cartpool itself. And what they're showing is that all the data does help, but the difference between the two of only same domain data. So yeah, specifically, we're looking at the green and the yellow. There's not really a huge gap between the two, especially in the meta world example. And then here, pretty much it's like a controller environment. They just both learn to do the task too well. And then even on the Atari boxing, like the band here is so small that it's hard to see an improvement, if that. And for example, they're still training on all of the other Atari games. So having just an image input for a reward sample, and I put the Atari boxing up on the top right if you haven't seen that in a while, but it's just two sort of agents interacting with each other very sparsely. And it doesn't help the game doesn't help it learn. On the bottom here, one thing that I want to highlight is they have this base control and an expert. So they're saying behavior control is the other algorithm, which a big issue that I have is they don't say the parameter or the number of parameters that the baseline or the BC-IMP model has as well. So it's hard to compare this model to the other one because this could be somewhere on, I don't know, 10 billion, 100 billion parameters, where this is only 1.12 billion. But what they're arguing here is that the more parameters you have, the higher jump start to the other tasks you have, which makes sense. But they're just trying to claim that the more parameters that you have and the more data that you have, the better this model is going to do generally. Which
That's general for all the.
yeah, I mean, that's just the general curve that we always see. But the reason why I want to bring all of this up is because they end up going to the next slide. They put this in the appendix section, and it really disappoints me because they put it in like section J of their appendix. But what they do here is they're taking out the robotics tasks and trying to show whether or not adding in the vision and the language into the robotics tasks actually helped it. And we actually see negative transfer here.
Yeah.
And so this is the same domain. The green is always on top, whereas all the data here is going to the yellow line. So adding in data for this model is actually worse in terms of performance. So even with the smaller parameter model, quote unquote, you're getting negative transfer by adding out of distribution training data. So in my opinion, flat out, I'm saying, no way, this is definitely narrow AI.
Mhm.
And adding the new data doesn't help with this size of model. However, yeah, they're basically claiming, and even the head of OpenAI is like, even tweeted out that compute is the next step up, and they were trying to recruit people even after GATO came in. So this is OpenAI being competitive, but they're saying that they're going to take these models and blow them up in the next 6 months, and we'll see. I don't know. I'm kind of doubtful about it. I think it's cool, and there's some interesting stuff to take with tokenization, but it's still only a single agent trying to learn multiple. The other counter argument, and I know we covered this over summer or spring, but the Jeff Hawkins 1,000 brains theory.
Yeah.
There's some talk about you need many agents that are learning different policies to some kind of mixed share policy instead of just one agent learning all of these tasks. So there's that paradigm taken into account as well. But In terms of time, I have 20 minutes left. I really did just want to highlight a lot of these different things, but that's the bulk of my presentation.
So one question,
Yeah.
comment I have is, I think the stumbling block is always going to be tokenization.
Mhm.
So very obviously, we don't tokenize well.
Yeah.
This is signing in, index numbers to things. Great. It does not work. This is not how humans operate, nor does it seem like an obvious solution. So they're using sentence tokenizer, something from 4 years ago.
Yeah.
Which is fine. But the way it works is it breaks down everything into subwords.
Yeah.
So my name, Noah, becomes 2 words, no and ah, which are both words that show up in the English language. They show up in all sorts of texts. My name has Hebrew roots. It is in no way related to the word no or the word ah.
Okay.
And by assigning a number not to my, because look, when you say my name or anybody's name, you now have a very specific individualized association to it. Now, I don't think of names as
But isn't
subwords.
that the argument of what deep learning is even trying to do, learning that latent space?
Yeah, but you're ignoring that.
Ruining.
No, transformers do not. It's context-specific embedding,
Yeah, but it doesn't matter. We're talking about tokenization.
but it's context-specific.
Yeah, sure, but
The initial
because
tokens that go into the model are wrong, so they are no sense.
not the embeddings, the tokens.
Oh, but the tokens themselves are created transformer.
In a
fashion.
lot of, I can't, this isn't true for sentence tokenizer, but for the bird tokenizer, you and I have the same token for our names.
Yeah, here,
Yeah,
it
but
says sentence piece, that's how they encode the words first, and then they learn the representations with their transformer or whatever.
Yes,
that's
so
the-
my name has 2 tokens, the integer. for
No, if
no-
it's split into
Subjects.
syllables
subjects.
and say you will use bird, then no in different words will have different embedding in the end as a token, and then use it as a token.
But it's.
I don't know what they do.
They break my name down into subwords. Bird just assigns a number to every word. It has like 1,000 or 10,000 words or whatever. But proper names that don't exist in its list, which is common, all get the same token, 100, which is unknown. So everyone in this room, for the most part, has the same token.
But you can do the fast texting, split everything into
So
triplets, n-grams, and then tokenize them contextually bird style.
okay, but we can't talk. Okay, but this is for the tokens that go into the models. So
Well, no, but then you've got all the n-grams,
Yeah.
and then they will be contextual, etc.
So
the context actually doesn't matter because when people think of
No, it matters. No versus no way.
no,
The no will be
no.
different.
That's the issue.
The
By
different
by breaking
embedding.
my name into subwords, you totally remove what my actual tokens would be, no matter what the context is of the sentence. When I think of Sergey, I think of you.
yeah.
I have an image of you, whatever the context is.
Well, even cross modality associations is lacking there, or are they? Because they're
I mean, obviously.
So what I was saying is deep learning would take care of this though, or like some
Not at all.
arbitrary number of
No,
learned latent space.
no.
How? I mean, even though there's still the subwords, you're gonna be in context with the rest of the string that's surrounding it. And it's going to learn the individual context. It's not gonna learn that it's necessarily Hebrew. It could if it's deep enough, but it's supposed to be that if you have enough samples and a deep enough
So-
architecture, you should be able to have all contexts.
So Noah, I guess it's more common now, but 10 years ago, it wasn't that common.
Okay,
So in their whole body of text, that name isn't going to show up very often.
so you're just saying data is the issue,
No.
not the model.
But then.
No,
it's
it's
context
not-
with
the model isn't
picture,
the
right?
issue.
It doesn't matter. It doesn't matter if your name was not popular 10 years ago.
It absolutely does, because when my name is now attached to 2 tokens or 1 token that every name is, because that's,
So you're saying it's the problem with the data, that's fine.
No, it's
with the
tokenize.
If you would encode words differently with a different type of tokenizer, for example, the ngram one, yeah, that's already much better than what they're doing here and what they're doing in version stuff.
Yeah, this is not a good tokenizer. It's old.
We're not even talking about the model, because I agree that in
Yeah,
the
we're
latent
not
space,
talking
we can
about the
find it, like, sure, in the latent space, but the problem is, how do you encode language into something that your machine can read, and that part, I think, is what's.
So it doesn't take in text. These models don't take in text. They
not trying to.
They take in a number associated with each word or subword.
Yeah, right, 32,000 subwords.
Yeah, they have an autoregressive that's trying to take it from tokenization back to its task.
Right. Yeah, but if those tokens are not like
But you-
well done, then you're learning the wrong thing,
The
right?
tokens are not well
Well, yeah, that's my point.
So even if though they're not well done, they're still producing very decent captioning, I would argue.
done. Maybe. I mean, you pointed out some flaws with it. right?
Oh, yeah, I mean, it's
But
still
also
being
we're-
general, but
So your primary question was, what do we think about AGI?
yeah,
And there isn't a doubt in my mind that we cannot achieve AGI without fixing how we tokenize. And so we spent all this energy, these practically billions of dollars on making models on tokens that aren't very good.
Or maybe
Just
that's-
logically, rationally aren't good, and tokenizers that are old.
sure. So I think another motivation of this is they had a lot of these already pre-trained and already done. And so they just tried to throw the kitchen sink at this as well, so which is what was sitting around. And so that's why it's probably the older style of tokenization of the language task.
Well, I think generally,
Um,
there's not many people doing research though on making better tokens, because most people are just
Yes.
like, yeah, let's just throw whatever.
So another argument,
That's like the main thing if you want to work with the language.
yeah,
So they don't really check, I mean, yeah, you're correct, like nobody's actually spending time on any new tokenization.
Yeah.
It's already there.
It's kind of funny because I think that's what LaCroix was doing very early in his days. He was like, oh, we can do like the digit recognition from like photo, right? That's just the first thing. We should do something similar with like language, right? Where you can encode it, like it can learn it directly from the language. Like it is pretty crazy in a way that we are doing this like weird wonky, you know what I mean? Like, yeah, I agree with that. It's wonky for sure.
Yeah, and they have tried like character-based things, but I don't think that works as well either, because just understanding the letters in order doesn't.
Yeah, that's just computationally more expensive if you want to.
One thing that, I think it was LaCroix or Hinton, when I was looking at this, they basically said, in the argument of scale is that since our brain has trillions of synaptic connections, that our parameter set needs to get up to trillions before we even start seeing generalists.
Which is by the way not true because this is a point neuron and it probably already has.
I completely agree. I don't know enough about tokenization. I'm gonna go into the arguments one way or the other, but it's interesting.
But I do think.
I do agree it's the crux of their whole thing, and thinking about at least the arguments of some of the more famous people.
You guys should call them out on Twitter. I really like
Less
honestly.
than the other 100,000.
They're welcome to watch our recordings.
Yeah,
But it's the same as pre-processing as MRI, you know what I mean? Everybody wants to do deep learning, but nobody wants to learn how to do pre-processing of your MRI.
Yes, absolutely, absolutely.
And that thing's
And that's
not worked on.
egregious.
That's
But
not.
Xenia wants to learn how to do pre-processing.
There are people who do work on pre-processing.
No, for sure.
but they're not the deep learners.
Yeah, but that's what I mean. Yeah, that's kind of the same.
Yeah,
But one thing which I'm actually pretty curious about here, like they do different tokenization embedding for different modalities. Right? I mean, we generally do, when we say multimodalities, we are basically having different embeddings for that. But I still find, I still think that the way to normalize all these tokenizations, it's pretty simple. I mean, you're not really learning from all of those different modalities just by averaging these tokens. So I really think like people can spend more time on that aspect too. I mean,
Oh, Alex is doing some of the work on that when he's putting this mutual information
That's-
sort of
yeah.
cross model, and you get unimodel
Right.
embedding that is influenced by other modalities.
Well, this is the thing that I was gonna say too. I just think this is kind of really boring. You know what I mean? Like, obviously it's gonna get better with more parameters and more data and whatever, but the more interesting thing to me is, like, especially how can we do it with less parameters? You know what I mean? Like, I understand that this is like a business model, it's the best thing, capitalism, this is the most logical way. But I just think in terms of like interesting, like in terms of questions of like life and how to do these things and how learning works, I think it is like magnitudes more interesting to be able to do this on smaller networks, even if it's worse, because then you can really understand kind of how does like sharing representation stuff work. Because I'm not convinced that this is sharing that much representation, especially because of that relation.
Well, it's trying to do exactly what you're saying. They specifically have these giant 100 billion parameter models that they've come out earlier in the year, but they decided to scale that down 100 times to be able to fit on the newest GPU. And so as the GPUs go up, as well as anything in our field does, the compute goes up, the performance goes up. It's just linearly, I think they've showed this, and also log linearly they showed this. But in terms of what they can do in the future, I think it's going to be limited to our software, hardware.
But I think I agree with Dr. Chris when he said what Alex was doing. So he also shared one paper which was related to domain adaptation.
Mhm.
But I never see anything related to domain adaptation in any of these papers. You're basically using different modalities. And I mean, I'm actually reading those papers as well because it's pretty interesting.
So taking basically like motor task and trying to apply it to language.
Yeah, I mean, why not? I mean,
Yeah.
if you do that, you will definitely scale it down much better.
I also think it would
Can I-
be interesting to just see more catered data sets where they have data sets where the modalities are sort of simultaneous, right? Where you have a motor task where they are also doing image identification, where they're also like listening to someone talk and trying to tokenize the words or whatever. Like easily you could have labs set up these kind of really cool, rich data sets, and they just aren't explored that often.
Yeah, 'cause I think, go ahead, please.
Yeah, like just a comment, because it's back to your, a little bit your conversation about take a motor task and apply it to the visual task. When in the beginning you were talking about it, the image I had in my head is my dog is trying to figure out which toy do I want her to bring to me. It's like, what do you want me to do? And she's trying, but then like that's the learning process. There is visual information. There is some blubbering that's coming out of his mouth, or like whatever is that. And so like, but that's, I think I would have, it would be interesting to hear narrative of a kid learning language by doing like, oh yeah, pick up this red toy. What that means? No idea, right?
Yeah, and it's like,
data set at MIT where they build the process of.
Oh yeah, I've seen that. That's an old data set. Yeah, I've seen a TED talk on it.
At least and I'm thinking out loud right now, when they talk about even taking notes in a classroom, you're supposed to write it down and then talk about it later and have different like ways of interacting with a new piece of information. You'll understand it better.
Ksenia has a 20-minute YouTube video on how to learn, but it's in Russian.
Oh, okay. But anyway, I was just thinking out loud and just thinking about that in terms of like if I was talking about a new piece of information rather than just writing it out or trying to visualize it for myself.
Well, like if there was a multimodal block in your head and you needed to push information through it back and forth, something. I mean,
Well, yeah, that's why this seems so narrow AI, is because they're just doing tokens and then just predicting, like, I don't know, I really don't. I don't just think.
Well, that's why I kind of wanted to talk about it because I do have many problems with this and I agree that
I think it's a great choice.
definitely an issue.
No, the work that you've done is pretty great, but then the only thing that you're showing is like they have a lot of compute, they have a lot of money, and they have a lot of parameters, and that's all. Right, you can just combine them and just do the prediction.
Right, and I think people should be doing that, but I'm just saying, like, seeing a paper every month or something that does this, and it isn't really improving on like the question of like how do things learn. To me, it's just kind of boring. It's like, yeah, okay, next month there's going to be a 1.5 trillion model, and it's going to do a little bit better. Okay, I don't really care. Like, it's just like, okay, it doesn't tell me anything.
I heard today in a podcast that is called salami publishing, because you're like chopping off.
Yeah, where's the 100,000 trillion model, and then we could just go.
They also have 20 people directly just working on this problem too.
Oh, yeah.
It's not only the compute, but they have the people power, right?
No, but maybe we're just jealous. Let me give you.
I'm definitely jealous that they.
No, the Stanford paper looks cooler to me, actually, the one that they compare to.
Yeah.
They're doing it in their lab and they don't have a million TPUs. They're just five in and. And how do we GATO on like half of the path that they compare them on?
Vibes, bro.
But yeah, that's sort of my presentation, and thanks everyone for.
Yeah, very cool paper.
chatting. I know we have 5
Yeah,
minutes. I
thank
kinda
you.
wanted to cut us off earlier, but
Thanks.
I got
for
it. It's nice.
Okay, I gotta figure out how to.
it's fun. I think there's a lot of promise there. It's just gotta